Let's discuss the advantages of this new type of memory. Now, DDR3 memory is not a radical departure from DDR2 memory, but more of an evolutionary next step in memory design. In terms of its design and working principles, it's not very much different from the previous generation DDR2 memory. The first improvement to the design is an increase in the frequencies that DDR3 memory can sustain beyond those of DDR2, simply by doubling the data prefetch buffer from 4 bits to 8 bits. This implies a doubling of the internal bus width between the actual DRAM core and the input-output buffer. Now, this provides a more efficient data transfer rate without faster operation of the actual memory core, since only the external buffers have to work faster, thus lowering the core memory frequency of the chips in relation to the external memory bus. Because of this lowering of the core memory frequency, DDR3 memory can almost immediately hit higher actual frequencies than DDR2 SDRAM. This sounds great, but while the previous lowering of the memory core frequency also increases the memory bandwidth, it also increases the memory's latencies. It appears that the increase in bandwidth available to the memory bus can make up for the increased latencies, but only slightly. Other useful improvements in the technology consist of lowering the default voltage of the DDR3 memory to 1.5 volts. That is roughly 20% less than a typical DDR2 DIMM working at the same clock speeds. This corresponding power saving results in some calculations that demonstrate a roughly 30% reduction in power consumption comparable to DDR2 memory working at the same clock speed. Now, this power improvement is coupled with other improvements in the physical DIMM package and an increase in the number of the internal contact pins per chip, which also results in improved signal quality at higher frequencies. Finally, the DDR3 specification introduced some improvements to the DDR3 SDRAM signal protocol, since the memory bus frequency increased significantly. The change in the way signals are sent to the memory modules is called flyby topology. In DDR3 memory, signals to the individual memory chips are not sent to all the chips at the same time, but one by one. Designers had to change the data reading and writing algorithms to address this significant change. Now they use the new flyby topology with on-module termination to the transfer address, management, and stabilization commands. This forces the DDR3 controller to successfully recognize and process time shifts on data as is received from chips for command transfers generated by the flyby architecture. This new technique is known as read-write leveling. In summary, the new DDR3 memory will provide for greater memory speeds in the future and more reliable data handling by the memory bus, but has increased memory latency. Currently, memory bus speeds are not high enough for the advantages of DDR3 memory to be demonstrated. At current memory bus speeds, DDR2 memory is roughly comparable to DDR3 memory speeds. That said, the industry will move to DDR3 in the near future, and we should expect performance to improve over time.